Before we touch any CAD software, before we wire a breadboard, and before we start coding, engineers sketch. Not because sketches are pretty, but because sketches help us think. In this video, I'm going to show you how to use Tinkercad Circuits as a digital technical sketching tool to plan circuits clearly, logically, and intentionally, the same way engineers do in the real world. I'm Dr. P, and this is Dr. P Learning. In my experience, students think that technical sketching is optional. They want to jump straight into building, wiring, modeling, and figure out as they go. That usually leads to frustration, rewiring, and wasted time, frankly. Technical sketching solves that problem. A technical sketch is not artwork, it's a thinking tool. It allows you to plan before you build, see connections clearly, catch mistakes early, and communicate ideas to others. If you can sketch it, you can build it. The reason we're using Tinkercad Circuits is because it acts like a clean digital sketchbook for your electronics. This isn't about simulation accuracy. This is not about pressing start simulation yet either. Okay? This is about layout, logic, and intent. Tinkercad lets us place components, arrange them logically, and visualize how a circuit should work before we ever touch a physical hardware. A technical circuit sketch answers three questions. What components am I using? How are they connected? Why are they connected that way? If your sketch does not answer these three questions, it is incomplete. We're not guessing, remember, we're planning. Before placing anything, stop and identify your components. For this example, let's say we are sketching a basic system with a power source, a breadboard, an LED, a resistor, and some wires. Okay. In Tinkercad Circuits, I placed these components without wiring anything yet. This step is about inventory, not connections. Engineers always know what parts they're working with before they connect them. Next, we arrange components intentionally. This is one of the most important sketching details, okay? And skills, really. Power components go in one area, inputs go in another, outputs go in another, okay? We don't just scatter parts randomly all over the place, okay? The goal is to clarify. If someone else looked at your sketch, they should be able to understand what the sketch does without you even explaining it, okay? Layout communicates thinking. Next step, we begin with connecting components. Every wire you draw should have a reason. As I connect a wire, I ask, where is this coming from? Where is it going? What is its purpose? In a technical sketch, wires are not decorations. They represent real electrical paths. If you cannot explain a wire, it doesn't belong in the sketch. Okay? A good technical sketch includes labels. So in Tinkercad, it could be some narrating component. It could be using notes, or it could be verbally explaining connections as you place them. Okay, but if you're doing this and turning this in as on paper or digitally, you'll definitely want to be able to add those notes on Tinkercad from the notes section. Okay, but this is how engineers communicate ideas clearly. Okay, if you're working on a team, okay, a labeled sketch prevents confusion and mistakes later. Before building anything physically, we've got to make sure we verify our logic before the building, okay? So we got to pause, Review the sketch and ask, does the power flow where I expect it to? Are inputs and outputs clear? Okay. Does this design actually make sense? Right? This step saves enormous amounts of time in real classroom labs and in the real world, frankly. Okay? Fixing mistakes on a sketch is fast, and fixing mistakes on hardware is slow. All right, let's be clear. This is technical planning, engineering thinking, visual problem solving. This is not the final CAD, a perfect simulation, or trial and error wiring. Sketching is the bridge between your ideas and the execution of those ideas later. Okay? In engineering classrooms, technical sketching should happen before the building, before the wiring, and before the coding. If a student cannot sketch their idea, they're not ready to build it yet. Okay? It's not punishment, even though sometimes students feel that way. It is professional practice. Technical sketching is one of the most important engineering skills you can develop. Using Tinkercad Circuits allows us to plan clearly, think logically, and build with confidence. If you want to see how this sketching process connects directly to physical builds, breadboards, and Arduino projects, check out the related video in the link below. Sketch first, build second, debug less. Thanks for watching. If this helped, comment sketch and let me know what system you want to plan next. I'm Dr. P, and this is Dr. P Learning. Have a great day.